Let's start from the next topic, projectile motion.
This question, what about attendance?
Attendance, don't worry, I am taking the attendance. I'm looking at your, and it's automatically recording that who is login and all this. Don't worry about that, inshallah. You focus on the material and practice a lot, inshallah. Okay? Attendance with me, la mushkila.
Teacher, this book and this question in your book, college physics,
Yes, college physics, yes.
page 63.
Yes, page 63, that's right. Okay. So we are going to study projectile motion. You know what we discussed before this in chapter number 2, that if you are driving your car or you are walking on the road, you are in one-dimensional motion along a single line, x-axis in that case. The line may be straight, it may be curved. Similarly, one-dimensional motion y-axis, an object is going straight up or coming straight down, that was one-dimensional. But if you kick a football to give it a pass to your team player, you might have seen that once you kick it, it goes in higher and higher in the air. The vertical height y increases, and then after going to the maximum height, it starts coming down. So y decreases, and it comes to the ground, and also it travels horizontal x displacement distance. Okay, so projectile motion or two-dimensional motion means motion of the objects like football or missile or any rocket from the rocket launcher. It has two dimensions at the same time. The object is moving along x-axis. It has x component of the velocity. Similarly, it has y component of the velocity and y displacement. At the same time, motion in two dimensions. And at your level, we assume that there is no force of friction, no horizontal force, only force acting on the object. The object, we call it now projectile. Only force is, the gravity. The force due to gravity is acting on the object, whether it is going up or down. So this is a two-dimensional motion. Now we define it. Let's try to understand the projectile motion. So as you see here on this slide, a projectile is a body, is an object. When you throw it in the air with an initial velocity v0 or vi with an angle theta, you see this is theta with the x-axis, and then it moves in two dimensions, as I told you, under the action of gravity alone. Only force acting on it is gravity, because at your level we assume that there is no other force acting on the projectile. Its motion is called the projectile motion, and the shape of the path, you see this blue curved surface, curved line, this is the path on which the object travels during its motion. So this is the shape of a parabola, like circle, square, rectangle. So this shape is called parabola. So the examples of the projectile motion, you see a golf ball hit by a player, like in this case, it goes up and then comes down and travels, you see the height is increasing. Here it is maximum, and then it again decrease and y becomes 0. Also it travels the horizontal x distance going here, right? So a bullet, another example is bullet fired from a rifle, from the gun. And the third example we already discussed, a football kicked by a football player. We assume two things here, as I discussed with you. The first thing, that the free fall acceleration g is constant over the range of motion, which is 9.8 meter per second square. Okay, whether it is going up or down, it is the same, g 9.8, with negative sign of course due to gravity along the negative y-axis. And the second, effect of air resistance is negligible, that there is no air resistance is 0. Now you see, as I told you, that when you start the motion in the beginning, you see this is x-axis line, and you throw an object, making, this is initial velocity and this is theta, this is the beginning, then it goes like this way. Okay, now you see, in the beginning this is vector vi, initial velocity, this is theta, and you have done that last lecture, that when you have any vector a, for example, any vector a, this is theta, this is ax, which is a cosine theta, this is ay, which is a sine theta. You did it. Similarly, instead of a here you have initial velocity vi. So if you find its two components, so this is x component, this is y component. On the next page I am doing it. You see this one, this is, as I told you, this is initial velocity v0 or vi, whatever you call it, the same meaning. Okay, so I would write initial velocity x component, as I told you, x-axis and y-axis separately. So first let me tell you the x and y component of the starting, the initial velocity in the beginning. Okay, so if this is your initial velocity vi, this is initial velocity x component, like a cosine theta, so vi cosine theta. Here you have y component, okay, is equal to vi sine theta, like we did before. This is what I have written here. So x component of the initial velocity and the y component of the initial velocity we have decided in the beginning. Keep in mind, you will be using these things again and again in this topic and also in the questions. Now, as I told you, we have two types of motion at the same time, but they don't depend upon each other. They are independent motions, right? So this is two-dimensional motion, two independent motion. As first, let's discuss x component of the initial velocity, which is this one. As I told you, this is the vi or v0, same meaning by the way, and I'm writing here constant. As I told you, you will be moving in two dimensions along x and along y at the same time. So let's decide and discuss which velocity will be same x or y, or which will be changing x or y. We'll decide and we'll be using that concept later on. You see, first of all, x component of the velocity, as I told you, it remains the constant. Why? I am going to explain. Give me 1 minute, you will get your answers inshallah. So this is what I already, this is nothing new, the same thing I'm writing, v0 or vi cosine theta, this thing. Okay, now why it is constant? Because you know, you have this x component of velocity remains constant throughout its motion, because no horizontal force acts on the projectile. You know that if you have a chair, for example, if you don't apply some force on the chair, it will not move, it will not change its velocity. So if there is no change in the velocity, same velocity initial and final, for example 2 meters per second minus 2 meters per second, you will get 0 change in velocity. Once velocity is not changing, so change in velocity over time, you get acceleration. So acceleration will be 0 when there is no change in the velocity. So x-axis acceleration is 0, right? You see, you have this equation. We did very first equation of motion in chapter 2, Vi plus AT. So Vi here, since we are talking about the x component, so I write here Vix, and AX, acceleration along x-axis. As I told you, there is no force along x-axis, so there is no acceleration. I mean 0 acceleration along x-axis. So I put this 0. I'm left with this one only. Final velocity x-axis will be Vix, and Vix is equal to what? Vi cosine theta. That's why I'm writing here the same thing, Vi cosine theta. Okay, so this is constant. Why? Because this is time. If you have time in the equation, different time, different values, so will be changing. So Vix will be the same, x component of the velocity will be the same. This is one thing. Okay, now we decided that x component of the velocity will be the constant from the beginning up to the end. It will not change. Keep in mind, please. Right. Now we discuss about the vertical component, which is V sub y, is continuously affected by the force of gravity. You remember in the beginning what I said? No x force, only force y-axis, which is gravity. So when you have gravity, so if I write the same equation, this one for y-axis, this is x-axis I wrote, and x-axis was 0. Now I'm writing the same equation for y-axis. So y component of the velocity will be equal to Viy plus Ayt, and you remember this Viy is equal to Vi sine theta. So I'm putting this Viy here, this one Vi sine theta, and acceleration along y-axis we discussed in chapter 2 also, that it is minus g. So this is minus g multiplied by time. You see, this equation is different from the equation for the x component. Now we are going to decide whether this will be constant along y velocity will be same constant throughout, or it will be changing with time. Now as you see here, this is time, right? You see this time multiply with g. You see this time? Can you hear me, please? Can you hear me? Hello? This is multiplied by g. So for example, if you are at time 0, so this will be 0. This one will be 0, and it will be simply equal to Vi sine theta, which is just the beginning, right? Y component. And then time 1 second, 1 multiplied by this 9.8, you will be getting some less velocity. So it means when you are passing with the time, the y component of the velocity will be decreasing. Okay, so I believe you can hear me, right? Yes, can you hear me, please?
Teacher,
Yes.
you have problem, teacher.
What's the problem?
You can see
Yes.
the board.
Again.
Okay, now
Is it okay now?
now we can.
Okay, okay. Right.
It's enough screen.
Yes, yes. You cannot see the screen. Your network problem with your one. Please, if you are you in the college or outside? Okay, so how many students can see my I mean the screen? Or can you see the screen? Please tell me if you can see it.
No, I see it.
Can you see it?
See it.
You can see it?
No, yes.
Okay, so some students can see, some cannot.
Can you repeat this? Some can see it, some cannot.
So what does it mean? It means it's not problem from my side then, huh?
No, okay, but you can repeat this.
Which one? Which one? Which one should I repeat? Please tell me which you want to repeat. The same page which you see, should I repeat? From the first page? This page, khalas. Khalas, khalas, khalas. No problem, no problem, no problem. Listen, please. You see, as I told you, that projectile motion is a motion at the same time in two dimensions, x and y. Now, it means you'll be having x and y displacement. You'll be having two types of velocity, one along x-axis, one along y-axis. So we have to decide with the information available what will be the x component of velocity from beginning up to the end, and how what will be the y velocity from the beginning up to the end. This is our objective at this page at least. Now, I told you that if you have this equation of motion we did in chapter 2, this one. Now we will use this equation for x-axis and then for y-axis. If I use for x-axis, it is on the left here as you see. So final velocity along x-axis or at any time Vix plus a t mean a sub x, acceleration along x-axis. As I told you, this will be 0. Why? Because as we assume in the beginning that there is no force along x-axis. So no force means no acceleration. So this acceleration will be 0. So I have only Vix, which is x component of the velocity. X component of the velocity we already calculated here, Vi cosine theta. You did in chapter 2 also, in the beginning of this chapter also. So this is Vi cosine theta. Now, what does it mean? Because there is no time, because time multiplied by the 0 acceleration in along x-axis, you will get 0 all this. So time is not involved in this. So it means that it will be constant from the beginning up to the end all the time, right? So it means that, as I told you in the beginning, that two types of motion. You see, I would write this is x motion, this is x motion, same. Even on the top it is not 0, x motion, same length, same direction. So x-axis will be the same. But what about the y-axis motion? We use the same equation, this one, for the y-axis. You see, I'm using the same equation, this equation for the y-axis. So I have here a sub y, acceleration along y-axis is minus g, we have done in chapter number 2. So what I'm doing, Vi y, which is Vi sine theta, this one, and this one is minus g. So this is the equation for y-axis. Okay, this is, it's okay now. There's a problem with them. Okay, this is the y-axis velocity, right? And as you see here, there is t multiplied with g. It has great meaning for you to understand this equation. You already finished with this one, that x velocity will be the same throughout from the beginning up to the end. Even on the top it is not 0. But y-axis, you see, this is time. For example, in the beginning time is 0 seconds. 0 second multiplied by 9, it will be 0, just the initial starting y velocity. If you have time 1 second, 1 multiplied by this 9.8, you will be having one number with this vi sine theta minus 9.8. You will be getting at 1 second less velocity than the starting. And again, if you have 2 seconds, 2 multiplied by 9.8 will be 19.6. You will be, your answer for y velocity at that time will be even smaller than the first 2 points. So if you keep on time increasing, you are going up and up, this is decreasing. Okay, how we show it on this projectile motion path, y, for example, y is in the beginning this one, then y is decreasing, and here y velocity become 0, but x still have some value, but y is 0 on the top. Again y will start increasing, but downward, mean along the negative direction. So it will be increasing, but along the negative direction. This is due to the equation we have and due to the time, in fact, you see. So this is what we have here. Now there will be a time, for that time, when that time multiplied by g 9.8, you will getting this number and this number the same. For example, I say okay, now 126 minus 126, you will get 0, mean y velocity will be 0 where on the top here. So you see, this is velocity, y velocity 0 at maximum height, but still you have x velocity. This is what I have used, the same length of the line and the same direction. So x velocity, you see, is the same throughout. But what about y due to this time factor? Look here please, this is y, for example, at the beginning, then decreasing becomes 0, but then it starts increasing, but in the negative direction, downward, you see, downward. So increasing. So keep in mind this thing please. Now there is another thing which is very important. Sometimes you can find it in multiple choice questions, that what will be acceleration, vertical acceleration on the top. So don't say this is 0, it is minus g, as we discussed that when the object is going up, coming down, even on the top, acceleration due to gravity g is downward, minus due to the fact that it is acting along the negative y-axis downwards. You see, g minus g minus g minus g. So at all points, x component of the acceleration is 0. We just discussed in the beginning that no force along x-axis, so no acceleration. But acceleration due to gravity is at all times, it is minus g, mean minus 9.8. Now please focus on this page. It's really very important for you to understand the basic ideas for projectile motion. It is just a summary, you can say, to have a good idea of all the parameters, the quantities. You see, here I have quantity. Of course, this is two-dimensional. You will be having horizontal motion, x motion, and this is vertical motion, mean y motion. Okay, all right. Now let's decide about the force first. We already discussed, by the way. Force present, yes or no? So horizontal x-axis, no force. We discussed already. No force mean Fx is equal to 0. Vertical force, yes, the force of gravity only. Which direction? Downward. Acceleration, present, yes or no? If present, what direction? You see, horizontal x-axis motion. So since you have no force, so no acceleration, mean acceleration along x-axis is 0. Let's decide about the y-axis, vertical motion. So this is x, this is y. Now you see here, vertical force present, yes, downward. Now acceleration, Once you have force, you have acceleration along the y-axis, a sub y. Okay, so this is minus g, minus 9.8. It is constant 9.8 with negative sign all the way up or down or on the top, so downward. Then velocity, constant or changing? If changing, at what rate? You see, x-axis we just finished, it is constant. So what is the value? This is Vx or Vi, cosine theta. This is the value at all the time. Y-axis velocity changes by 9.8 meter per second every second due to the acceleration due to gravity. So Vy, we finish that Vi sine theta. V0 or Vi same, don't mind it. So Vi sine theta minus gt, this is what we just finished last page. Then in general position, you see, this is the second equation we did in chapter number 2. We'll be using separately for x and y components of the velocity here. So along x-axis you have v0x or vix multiplied by time, which is vi cosine theta multiplied by t. Okay, and similarly for y-axis we have vi yt minus half dt square. So y component of the velocity is vi sine theta. We put the value. So with the practice of time you will learn all these things, don't worry. Now you see, when you are throwing some object, you are kicking a football, or even on the technical scale, if we talk about the bullet or the rocket launched from the rocket launcher, fired from the rocket launcher, you may be interested to find the maximum height of the object, and sometime how much maximum height, sometime how much time it took to reach maximum height, and how much horizontal distance it will travel, all these things. So we'll be discussing one by one and calculating. So first of all, let's calculate the maximum height. As we discussed, that once you have the projectile motion, y velocity will be decreasing at the maximum height. It becomes 0. Okay, at y max, y velocity becomes 0, but x still you have the same. Okay, x will not change. So this is the equation third we use for this one. Y velocity is 0, right, at maximum height. So this is vi y minus 2gy. This is the last equation of the motion, third equation of motion. Now vi y square or v0 y square minus 2gy, I take this on the other side, it will become positive, and you can find this y or y max vi square divided by 2g, and again vi y we finish in the beginning, that vi y or v0 y is vi sine theta. So instead of this we write vi sine theta. So you will get y maximum, this one. It's simply mathematics, nothing else. It's simply rearranging the equation, so easy. Now time to reach the maximum height, we call it t sub max. Okay, so we use this equation, first equation of motion, vf is equal to vi minus gt. So as I told you, on the top y velocity is 0, so this is 0. So v0y or viy minus gt. If you take this on the other side, it will become positive, so divide by g then. So t max is equal to this much, and again this is v o y or viy, the same vi sine theta. You substitute here and you will get the t max. Keep in mind, t max is the time you start from this point and all the way you go on the top up to this point. So the time you take is called t max. It's not the total time, by the way. Total time now we are going to calculate, right? So this is your total time now. I mean, the total time your object, your projectile will be in air. It will be suspended in air. It will be hanging in the air. We call it total time of flight or hang time. This time is equal to 2 multiplied by this time. You see, you start from this point, from the ground, for example, you reach the maximum height. For example, if you take 4 seconds, again you will take from maximum height to the ground 4 seconds. So you multiply that by 2. So this is what we do, 2 multiplied by T max. So T max you already calculated, Vi sin theta over d. So this will be the total time of flight. So keep in mind, in the questions, in the tutorials, exams, when you are going to calculate Y maximum, so you have to use T max. Then you may need, for example, if you kick a football to give pass to your team player, you might be interested to know how much range you covered, how much total horizontal distance you travel, your football traveled. Similarly, for the missile and other rockets launched from the fire from the rocket launcher, you might be interested to find how much horizontal distance. So range is nothing, just we call it the horizontal distance is called the range R. Okay, so range R mean it's simply horizontal distance. So horizontal distance traveled by projectile is called its range. You see, you have done this. V is equal to del x over del t. It gives you del x is equal to, del x is equal to v multiplied by delta t. So this is what I'm writing here. Instead of delta x, I'm writing x. Instead of v, now I have vix or vox or vix, initial velocity component, multiplied by this time here. So this is nothing, this equation I'm writing. And now vix is equal to vi cosine theta multiplied by t. And now again, this is what t is the total time. On the last page we discussed and calculated that total time of flight is equal to 2 vi sin theta divided by g. This is what we discussed. Now you see, now you have to do mathematics with this equation. This is 2 vi, so vi square, 2 here, sin theta and cosine theta. Simply I'm writing the same thing but in a different form, over g. You see, you have one trigonometric identity which says that 2 sin theta cosine theta is equal to sine 2 theta. This is the trigonometric identity you might have done in the mathematics as a trigonometric course. If not, you remember this is the rule, a trigonometric identity. So 2 sin theta cosine theta, we will replace it with this one here, sine, you see, 2 theta. Okay, now if you are interested to find out the maximum range you need for your projectile or for your football or any object you throw in the air, if you need it to travel maximum range, maximum horizontal x distance, you see, what is this? This should be 1. So sine 2 theta should be equal to 1, and you know that sine of angle is equal to sine of 90 is equal to 1. So what does it mean? It means 2 theta will be equal to 90. So divided by 2, so theta will be equal to 45 degree. Means that if you throw the object making an angle of 45 degree, your projectile will travel the maximum range, maximum x distance horizontal. All right. Okay. Now this is the maximum range, right? If you have simple angle, you write this range, otherwise you use this one. Now we are going to do one last example for this chapter. This is on page 68. All right. You see, a long jumper leaves the ground at an angle of 20 degrees to the horizontal. I believe you can hear me, right? Hmm? I cannot hear you again. Please loudly.
Teacher, it's not the same question in the same page.
Maybe different because different editions, but you look at the example number. Look for example number 3.6, the long jump. The long jump.
No, its name is the rocket. 3.6, the rocket, not the jump.
You see the picture, the same picture you have in the with the example. Go with the picture, please.
No, we don't have the same picture.
A long jumper. Can you read it? This is the example. A long jumper.
This is 3.3.
Whatever, because different books. But look at this. A long jumper, please. A long jumper. 3.6. This is what I see. This is 3.6, huh?
This is page. And page 65, it's 3.3.
Oh, khalas. This is long jumper leaves the ground at an angle of, 20 degrees. Right? So angle is 20 degrees. Right? And initial speed is 11 meter per second. Right? Now, how long does it take for him to reach the maximum height? So the A part, first of all, we have to do, how long does it take mean to reach the maximum height? So T max you have to find out. You have the rule for that, which is VI sine theta over G. VI 11 sine of theta over G. You get 0.384 second. That's it. Easy. Now B part. Find the maximum height. You see, maximum height, we have two rules. First rule we have done in chapter number 2, but we'll use it for chapter number 3, which is VI, you see, T, 1/2 × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × gt square. And since we're talking about y-axis, so I write it VIY, and VIY is equal to y component of the velocity, which is VI sine theta. So we write VI sine theta multiply by t. Please don't make the mistake multiplying t with theta. Better you take it like this one. Okay, minus half. Now you can write VI how much?
11.
Okay,
920. Yes.
calculate it separately, but then multiply with the t. T how much? This t. This
0.3.
yes. Keep in mind you have to use t max for maximum height. Okay.
Okay.
Right. This is t max, not the total time. Okay. T is 0.384 minus half. So you get y max that's it. Then C part. Find the horizontal distance he jumps. You see, we have seen that the horizontal distance or the range we did two rules, so you can use any one rule. So VIX multiply by T, and VIX is equal to VI cosine theta separately T. So let me write it here. VI how much? 11, sorry, cosine 20.
Teacher,
Yeah.
you now calculate how the teacher.
Hmm?
Now you calculate how far the teacher.
Now we use total time because you are talking about x distance total. So if you use T max, that is on the top. So you have to multiply this T max with 2 because you need total time. I'm not writing T max here, sir.
Okay, right.
Okay. So
Okay.
2 multiply by the time 384. You get the idea, right?
Yes, I got it.
You get 7.94. And you have another rule we just finished. You can use any correct rule, you will get the same answer, by the way. Okay.
Okay.
With this rule, where is that rule? Range, this one, you see. So if you use this rule, you will get the same answer for the range and the x. Okay.
Okay. It's for range.
Yes.
Teacher.
Yeah.
Okay. This example
This is with the topic we just finished. The topic we finished, so we are using this example to learn how we use these equations to solve the problem. Huh? This is range. Range mean x distance. Sorry? Yeah. Right. Yes, please.
What should we study, teacher? That's why our book. We didn't say your place in the career what we teacher.
Now I will upload on the Blackboard, and I will upload on the YouTube channel also. You have my, you already subscribed my channel, sir.
Yes, teacher, but what we study? The book our
Book is for more practice. If you need the book, sometimes you have to practice more question, because the teacher we teach you according to the syllabus given to us, because we cannot teach all book. We just give you the idea. But if still you do this example by the teacher and tutorial and all these things, good practice, so inshallah, and a little practice in the book also, you have end of chapter questions also.
when you upload when
Maybe this night or bukra, inshallah. Ala sabah, inshallah, I will upload it on the YouTube. Now, D part, you see, D part, he says, used to find maximum height. You see, part B and D are the same. You see, you already finished B. What is the maximum height? Right? What is the maximum height? You just finished. This one here, you already finished. Right? And he's asking in D part again, maximum height. Use another equation. Right now he's asking you to practice, but keep in mind, in the exam we don't ask you use this equation or that equation. In the exam you have to use one equation, but right now for the practice, let me use that one to find the maximum height. Okay, you see, this is the equation we just finished, maximum height. This one, you see, this one, vi square sine square theta over 2g. Okay, we are using this equation now for the last part.
so this is teacher, this is for
Maximum height, yes. So you have two rules. In the exam you need only one rule. Any correct rule you do, that's okay, no problem. So we used one rule, any good rule. So one rule we already finished, you see here in part B. This is part B, y max. We use this one. Now we use another rule which I have just showed to you, which is y max vi square sine square theta over 2g, right? So 11 square multiply by sine of theta 20 square you would get exactly the same answer we did in B part with different formula. So it doesn't matter which rule you use. Okay, so this is end of the chapter now.